Okay, so here I'm showing you a histogram that we used in example 3.1. Recall what was it about that example. In this example, we had a list of 200 bills, telephone bills, that is recorded by the company. And what they did when we were learning the graphical methods, we said that in order to be able to make a conclusion out of this table, we wanted to summarize the data, and we used the histogram, which is widely used. Where, what did we do in the histogram? You can see these values there on the bottom of the rectangles. They represent the range of the bills. So, for example, the first one, in this column, we are summarizing or recording all the bills that are between $0 and $15. And in the second one, it's between 15 plus, okay, and $30, etc. This is how we read, or how do we interpret the histogram. So we are saying here that in histogram, the area represents the sum of all the probabilities. So let me show you how this is true, okay? And we're going to build on that. It's very, very important concept. So how do we, let's remember, how did we build the histogram? Try to remember. Yes, we built it from a frequency table, right? So what we did, we out of the 200, we have seen how many bills are between $0 and $15, and we found out that we have 71 of these. Okay, and that's why you can see that the column height of the first class is 71. Okay, you can see that here. So because we had 71 observations or 71 bills. The second one, we had 37 in the second class. So what did we do in the frequency table? Instead of having 200 different values, we cluster these, we classify these into categories, and the categories are the classes, right? 0 to 15 is one class, 15 plus to 30 is another class. So in other words, what we have done is that we summarized all the bills within 0 to 15 in one category. Okay, so it's like we were shifting from having a continuous data to a discrete data, where everything between 0 and 15 is all represented here. Okay, we have 71 of these. And then we have 37 are in the second class, we have 13 in the third class, etc. All right. Now, remember, what's the most common method to assign probabilities? Okay, I'm sure you still remember that. Yes, it is the relative frequency. Okay, so can you guess now what I'm trying to reach by asking you these questions? Okay, what I'm trying to reach here is this: that the height of any column, okay, when I divide it by the total number of observations, and here we have 200, okay, you can see that by summing up the values of each class, 71 plus 37 plus 13, etc., we have 200. So 71, we have 71 bills between 0 and 15, and these represent 71 out of 200. So which means 71 over 200 is the probability that I will observe a bill in the class or in the category between 0 and 15. And this is very, very important for us. However, we did not reach our objective yet. We're talking about the areas, okay? And we're going to use that a lot in the future. Why areas? How areas will help us to find probabilities. But are we there yet? Are we talking, when we talked about the height of the column, are we talking, did we describe an area? No, of course not yet. Okay, but we are almost there, right? Because the height of a rectangle is one element of calculating the area. So let's see where I'm going to reach here. All right, so we found that the probability to observe a bill within in the category between $0 and $15 is 71 over 200, right? Okay, what I want to do now is that I need to figure out a way that I want this probability to be found using an area. So let's see about the area of that rectangle. The area of a rectangle, it's equal to the base times the height. So in the first, for the case of the first column, it's equal to 71 times 100. Okay, as I mentioned before, I have the 71, but I don't have the 200 yet. So what can I do? All what I will do is that I'm going to change the scale of my vertical axis. So instead of being 1 to 1, okay, it's going to be 1 over 15 times 200. And these 15 times 200 are not arbitrary values. 15 is my class width and 200 is number of observation. You are allowed to do that. Okay, we used that before in our classes. I told you that you can change the scale without changing anything in histogram. So now let's check what would be the area now in the new scale. The area in the new scale, it's equal to, first, the height is now not 71, but due to the new scale, it's 71 over 15 times 200, right? Now, the area becomes what? The area is, again, height times base, so it's equal to 71 over 15 times 200, which is the height, and I multiply it by the base, and then which allow me that the 15 will cancel. So we have 15 here and 15 there. They will cancel out, and I will have 71 over 200, which is what? Which is exactly the probability that we found previously using the relative frequency. So you can see now that I'm using the area to represent a probability. And this is very helpful for our future discussions. Okay, so why it was very important for us to use areas as probabilities? Look at this. In this histogram, I could ask you the question, what's the probability that you will observe a bill between 15 and 30? And then you will answer it's equal to 37 over 200, right? Why? Because this is the number of observation in this class. But what if I ask you, I need to find out the number of bills between 50 and 95. This is across classes, and you cannot do that, right? You cannot do that because I'm not even taking for example, probability of all those between 30 and 45. I said between 50, right? Between 50 and 95. So it's somewhere here. And I really cannot tell what's the proportion here unless if I'm using areas. So let's take another example. If I want to find the probabilities of having bills between 20 and 50. Okay, so 20 is here and 50 is there. So, which allows me now to know that how to calculate part of the rectangle. So if I know that this is 20, right? This is 20. So which means this is 10, right? 20 to 30, it's 10. This is the base here. And this is 5. So I know this is 5 because I'm looking for 50 here. Okay. So now it's only a matter of finding areas. And this will be the area here. So for the first part, okay, I have a height equal. So let me show you each part of the area that I'm looking for. So the first one is this one. Okay, I need to find this area. And it has a height of 37, but on the new scale, it's 37 over 15 times 200. And I multiplied by the base, which is 10. Here we go. This is the base equal to 10. Then the second part of the area is this one. This one is easy because it's the full rectangle, so it's equal to 13. Again, on the new scale, it's over 15 times 200, but now I multiply by the whole base, which is the class width 15. And then the last part, which is only a portion of the third column, or in fact, it's the fourth column in total. The height is also 9, and the base is only 5, right? Between 15 and between 45 and 50, so which makes the base equal to 5. And now I'm able to sum up all these areas, and I will get these, and the final probability will be equal to 0.203. So this is what how I could use the areas in a histogram to find probability across classes. Okay, all what I did, I simply found the areas, and this is the probability. It's very powerful. Okay, so what does that 0.203 represent? This is the probability that the bill will be between $20 and $15. Okay. All right. In this histogram, we have a class width of 15. Okay. What if I reduce the class width, meaning that I reduce the category or the range of each category? Let's see, for example, I want to reduce it from 15 to 5. And here we go. I will use the same data that I used, the 200 values that I used to build the first histogram. And now I'm building another histogram where the category width or the class width is now 5. So you can notice, for example, within the 71 values that were between 0 and 15, now I broke it down into these 26, so 26 between 0 and 5, 26 between 5 plus and 10, and then 19 between 10 plus and 15. So if you sum up the values of this smaller rectangle, you will find that these make up the value of the big rectangle, of course. So what do you notice here? Look at this. When the rectangle base gets smaller, you can see now the profile of a certain curve. And how can you verify that? Look, I'm going to join the tip of the rectangles, of all these small rectangles, and look what I can observe. You can see that I'm approaching a profile of a curve. So imagine that I even decreased further the width of every rectangle. The curve will be even more and more elaborate, right? So this is what we are saying, that when we have a very large number of small intervals, then the histogram will look like a curve, and we're going to use a lot this curve, and this will be our first introduction to the probability density function.